section 14.4, we learned what a vector was. And in 14.5, we learned how to resolve a vector into its x and y components. Now we need to come together and learn how to actually add our vectors in a mathematical way. So here in example 1, we have these two vectors A and B. Now since they are at right angles to each other, this particular problem is going to be pretty easy because we know how to handle right triangles. Our A is 86.4, our B is 67.4, and so the result here, we'll use Pythagorean theorem. 86.4 squared plus 67.4 squared is going to equal r squared, and that's going to give us that r is equal to 12,007.72, and then to find r, that was r squared. To find r, we need to take the square root, and we see that this is about 110 if we round it to the nearest whole number. So we can get our sum when the vectors are at 90-degree angles to each other by looking at Pythagorean theorem. We can also get the angle of this from a right triangle because this angle here is going to be related by tangent, where we take our opposite side, that's 67.4, and divide by the adjacent side of 86.4. And remember, to solve for an angle, we use our inverse trig function. And so the inverse tangent here tells us that theta has to be about 38.0 degrees. So we found our addition by looking at these two vectors that were in a right angle. We're going to use this idea for any vector, even if we don't know that we're adding two perpendicular vectors. Because remember, in the last section, we actually figured out how to find the x and y components. And those x and y components are always perpendicular to each other. And so if we first resolve our vectors into the x and the y components, and then we combine the x's for each of the vectors, combine the y's for each of the vectors, then we'll be able to get our overall magnitude of this resultant vector by using the Pythagorean theorem. So whatever two vectors or three vectors or however many vectors you have, you simply resolve them all into x and y components, add the x's all up, add the y's all up, and use Pythagorean theorem. To find the angle, you always will set up that tangent of theta is going to be equal to the y component and the x component of all of your sums. So let's see how we can do that in practice. So if we have these two vectors, A and B, well, our A vector is here completely in the x direction. And so we don't even really have to do anything. All of A is in the x direction. None of A is in the y direction. But B is here at this 55-degree angle. And so for B on our x direction, we're going to have to do the magnitude 20.8 times cosine of that angle. And that gives us 12.5. And the y component of that vector is going to be 21.8 times the sine of 55 degrees. So our y component is 17.9. So our resultant here for the x will add 27.8 plus 12.5 to give us 40.3. Then the resultant of y is 0 plus 17.9, which is simply 17.9. And the overall magnitude of this vector is going to be the square root of the x sum, the y sum. So the square root here of 40.3 squared plus 17.9 squared gives us the overall value of 44.1. To get our angle, I've kind of run out of room here, so I'm going to go back over to the left. The tangent of this angle is going to be the ry, which we found 17.9, over the Rx, which is 40.3. And so theta equals the inverse tangent of this ratio. And we see that our theta is 23.9 degrees. So the addition of A and B here gave us a vector that is a magnitude of 44.1 and the direction 23.9 degrees. We'll do one more here, adding A and B. Now this time we have A as being at an angle of 15 and B has that angle 125. So first things first, we need to resolve these into the components. The magnitude of A is 570, and so the x will be times cosine of the angle 15. So it's 550.6. We'll go ahead and do the x, the bx. That's 350 times cosine of its angle, 125 degrees. And it should be no surprise, it's in the left direction, so getting a negative here is appropriate. Then we need our AY is going to be 570 times sine of 15 degrees. We get 147.5, and BY is 350 times sine of 125. And this one should be positive since it is going up. We're looking at 286.7. So overall, the Rx is 550.6 plus negative 200.8, giving us 349.8. The Ry is 147.5 plus 286.7. Looking there at 434.2. To get our overall magnitude, we do the square root of these two results squared. So it's a little bit of calculation, but they're always the same here, so at least you don't have to think quite as much about what to do. You just have to do it. So our magnitude is 557.6. To get our angle, it's always, you probably figured out, it's always going to go to this inverse tangent. And we do our Ry, which is 434.2 over our Rx. And so our angle here is the inverse tangent of 434.2 divided by 349.8. And we're looking at the angle for this result as 51.1 degrees.